Here is another problem that says a non-volatile solute is dissolved in water. What will be the freeze point of solution when the boiling point is 99.92 degrees Celsius? Before we solve this problem, let's just look a little bit of a diagram to see how we can solve this. Let's say here we have the scale of freezing point. Let's say FP. Let's call it to be FP. This is going to be 0 degrees Celsius. What about the point? If freezing point is 0 degrees Celsius, the boiling point here, let's call it BP, is simply going to be 100 degrees Celsius. So let's say the change in freezing point, this is simply going to be KFM. And in the case of boiling point, the change in boiling point, this is simply going to be KBM. So, and at this point, the KFM, or let's say the KF, is simply cryoscopic constant, which is approximately 1.86 degrees Celsius kilogram per mole. While in the case of KBM, the KB is also a constant, which is approximately 0.512 degree kilogram per mole. So let's say KF is what we said. KF is 1.86 degrees Celsius kilogram per mole. And in the case of KB, this is 0.512 degrees Celsius kilogram per mole. So, and the KB is a constant. So let's assume, in this case, and the LM, is the molality of the solution. Let's assume we are asked to find the molality using the delta TF, which we said is KFM. And at this point, we're asked to find the molality. Molality M is going to be delta TF divided by KF. What about in the case of delta TB, which is change in boiling point? Here is going to be delta TB. This is simply going to be KBM. And we're asked to find the molality. This is simply going to be delta TB divided by KB. So these are some basic things which we need to use to solve this problem. So here we are given the temperature, and at this point the temperature we are given is 0.92. What is our change in temperature here? Change in temperature is final temperature minus initial. And in this case, our final temperature is supposed to be 100 degrees Celsius, as we mentioned here, minus initial temperature is 99.92. Our change in temperature is simply going to be 0.08. So what you need to do next is to find the molality. Since we are given the boiling point, we are going to use this formula to find our required molality here. So since we said to find the molality is going to be delta TB, which is the change in temperature of boiling point, divided by KB. Our change here is 0.08 divided by KB, which is 0.512. Our molality here, if you divide 0.08 divided by 0.512, this is simply going to be 0.568. So our data here, we have the change in temperature. Here we have the molality, which is 0.568. So let's get rid out of this place. What do we need to find next? Since we said our delta TF is going to be KFM, and in this case, we said Kf, which is the cryoscopic constant, is approximately 1.86. This is simply going to be 1.86 multiplied by our m, which is the molality, which is what? 0.568. If you multiply this, we are going to come up with 0.29109. So this is the change in freezing point, which is 0.29109. But remember here, we said the freezing point is starting from 0 degree. Therefore, freezing point is going to be 0 minus 0.29109. So the change in freezing point is going to be negative 0.29109. And this is our final answer for this problem. Here is another problem that says a non-volatile solute is dissolved in water. What will be the free point of solution when the boiling point is 99.9?